Hi everyone, so we are now here again to discuss another problem from University Physics. So now we will be discussing a problem in chapter 25, exercise 26. So consider the circuit shown in figure 25.26. The terminal voltage of 24.0 volt battery is 21.2 volts. What are the internal resistance R of the battery and the resistance R of the circuit resistor? As shown in figure 25.26, the terminal voltage is 21.2 volts, where the EMF of the battery is 24.0 volts. The current is 4.0 amperes. We are required to find the internal resistance of the battery and the external resistance of the circuit. As the current moves through R, it experiences an associated drop in potential. We can apply equation 25.15 in this case to find the internal resistance R. That will be VAB equals EMF minus I times R. So to get R, that will be EMF minus V over I, where I is the current, and from the figure it is equal to 4.0 amperes. So now we can plug our values for E, V, and I into the equation to get our internal resistance. So we get 0.700 ohms. That is the internal resistance of the battery. In letter B, the terminal voltage represents the voltage drop of the battery due to the external resistance capital R, where the voltage across this resistance is the terminal voltage, and the current through it is 4 amperes as for the circuit. So we can apply equation 25.9 of Ohm's law to get the resistance R by using the values of V and I. That is 5.3 ohms. Hi again everyone. So we are now here to solve another problem from University Physics. So now we will be talking about problem 25.28. An idealized ammeter is connected to a battery as shown in figure 25.28. Find the reading of the ammeter, the current through the 4 ohm resistor, and the terminal voltage of the battery. So in this problem, the EMF is 10.0 volts. The internal resistance is 2.0 ohms, and the resistor is 4.0 ohms. We are required to find the reading of the ammeter, the current through the 4 ohm resistor, and the terminal voltage of the battery. For letter A, we want to determine the reading of the ammeter. The ammeter is a device that measures the current, and as it is idealized, there is no resistance. It has zero resistance and just acts like a wire. From the figure, the connection of the ammeter makes a short circuit between the two terminals of the battery. And in this case, the current through the battery is due to the EMF, where this current equals EMF divided by the internal resistance of the battery. Now we can plug our values for E and R into this equation to get the current that the ammeter reads. We get 5.0 amperes. As for letter B, we want to determine the current through the 4 ohm resistor. As we discussed in part A, the ammeter makes a short circuit and all the current that is produced by the battery goes through it, and no current flows into the external wire. Hence, the current through the 4 ohm resistor is 0. In letter C, the terminal voltage of the battery in this case is 0 because the ammeter acts like a wire with a 0 resistance, therefore, no load on the battery, hence, no voltage drop and no terminal voltage. So V equals 0. Hi everyone. So now we will be talking again about a problem from University Physics. So today, we will have problem 25.34. When a resistor with a resistance R is connected to 1.50 volt flashlight battery, the resistor consumes 0.0625 watts of electrical power. Assume that each battery has negligible internal resistance. What power does a resistor consume if it is connected to a 12.6 volt car battery? Assume that R remains constant when the power consumption changes. The resistor is connected to a battery and consumes 5 watts. What is the voltage of this battery? In this problem, we are given the EMF of the battery, which is 1.50 volts, where the resistor consumes a power of 0.0625 watts. Also, we can neglect the internal resistance of all batteries, where R equals 0. We are required to find the power where EMF is 12.6 volts and the voltage when the power is 5 watts. We want to find the power consumed by the resistor if it is connected to a battery with EMF equals 12.6 volts. To get the target, we should find the resistance of the resistor. Since the resistance is constant and internal resistance is 0, so use EMF 1.50 volts. We can find it using the equation P equals V squared over R. To get R, that will be V squared over P. Plug in the values. We get 36 ohms. So the resistance is the same. For the EMF equals 12.6 volts. Using the same equation and we plug in the values, we get 4.41 watts of power. In letter B, we want to find the EMF if the power consumed is 5 watts. By the same concept, if we neglect the resistance of the battery, the EMF equals the terminal voltage. So we can use the same equation to get the voltage with the same value of resistance. We get V equals the square root of PR. Then we plug in the values. So the voltage we get is 13.4 volts. So the EMF is 13.4 volts also.